Hello, and welcome to this lesson on rational exponents. In today's lesson, we will be covering a few things, but the main two things can be seen on this current slide. And we're going to be converting radicals to expressions with rational exponents and vice versa. And we will also be simplifying expressions using rational exponents and the laws of exponents. And we reviewed laws of exponents in a previous lesson video. Before we move on, we want to talk about some vocabulary words. And many of these things you might recognize, and we'll go over more in a second. Radical, radicand, and index are the three parts to kind of a radical form that you could be writing out. Exponent is fairly straightforward. A square root and cube root are similar. The difference with the cube root is you're looking for a number that multiplies by itself 3 times to reach the answer instead of 2 times for a square root. Prime factorization is breaking down a number into its smallest factors. For instance, 10 would be 5 times 2 because 5 and 2 are both prime numbers. And then a rational number in general is one of the larger groups of numbers that you can use in math. It is essentially any number that can be written as a fraction or if it has a repeating decimal. Some examples would be 5 over 1 for 5, 3/4 are 0.33 repeating. As a review of prior lessons, we can go through a couple of these warm-up problems. And for instance, let's start with number 1. So if I wanted to simplify the square root of 72, I'd want to break it down into a factor tree. I believe that's the easiest way to approach it. So a first thing I would do would be to split it into two things that I know multiply into 72. In this case, I'm choosing to use 9 and 8 because 9 times 8 is 72. And then I'm going to try to break down these two numbers into the smallest prime numbers that can go into them. And we can see that we don't have that many steps to go here. And I can break down this last 4 into 2 and 2. So that I know that my answer here is, for the factor tree part is done. So I'm looking for pairs of numbers that can go on the outside of a square root. So I have a pair of 3s here and a pair of 2s here. So I know that on the outside of my answer, I'm going to have 2 times 3. And for the 2 that I have left over is going to remain inside of the square root. So my answer for number 1 in this review problem would then be 6 times the square root of 2. In number 2, we are looking to simplify the cube root of 40. So we can erase what we have over there on the left to use that same area. And now we're going to do the cube root of 40. So a cube root of 40. And we're going to break this down once again into the factor tree. So we can do that as our steps here. So we have 10 and 4 multiplied to 40. And then we'll break this 4 into 2 times 2, and the 10 into 5 times 2. And that means that I have a triplet of 2's, which is going to go on the outside. And I have 1 5 left over, which is going to go on the inside of my cube root. And that means that my answer would be 2 cube root of 5, or 2 times the cube root of 5 to be more precise. So that finishes the first 2 word problems, or review problems. For the third review problem, I'm going to do the number on its own and then do the variable parts and then just put them kind of all together so that I can make this 12 into a factor tree of 3 times 4 and then 2 times 2. So with my pair of 2's and my 1 3, that means that this would end up as 2 times the square root of 3 equals the square root of 12. And so on this side, if we were going to do the square root of x to the fifth y to fourth. The easy way to do it is if I'm doing a square root, I want to kind of separate and look for numbers, the biggest numbers, biggest exponents that a 2, which is the index here for a square root, can go into. So what I mean by that is I'm going to write this problem as x to the fourth times x, which is the same thing as x to the fifth. And then the y to the fourth stays the same because it already has an exponent that 2 can go into. Now, to finish this problem off, I'm just going to do basically move that x to the fourth to the outside. And so its exponent will be divided by 2 when I move it out. And that's going to relate to what we're talking about today. And then I have y to the fourth being divided by 2 for the exponent. And then I have the square root of x being left behind. So let's put our whole answer together for number 3. So on the outside so far we have a 2. We have x to the 4 over 2, which means it's x squared. That's 4 divided by 2. And we have y to the 4 over 2. So then we have y squared on the outside. And then on the inside, from our number part, we have a 3, and our variable part, we have an x. So we can put those two together and make 3x to be on the inside. And that covers some review problems of simplifying radicals, and they will apply in this lesson as well. Some important notes on these few slides is that for rational exponents, it is basically a way of writing a radical without the radical symbol. So if you wanted to find the square root of something, instead of doing the square root, you can do the power of 1/2, and it would get you the same answer. And that applies as well to a cube root in the middle here and a fourth root on the right-hand side, in that you have, instead of a cube root, you raise something to the power of 1/3. In a fourth root, you raise it to the power of 1/4. And that pattern continues with more radicals you're finding. So now if you are looking at a problem, and basically these bottom ones are exactly the same. So you have like an r radical, basically the r is the index here, and then of whatever radical you're kind of doing. So for a square root, it's not going to be there, but it is going to be a 2. For a cube root, that r would be a 3, and so on and so on. Now, whenever you make a rational exponent or a fraction exponent, the numerator is always going to be whatever power something is being raised to, whether that thing is being raised to the power inside the radical or outside of the radical. And then whatever kind of radical root you're doing, whether it's a square root or cube root, all the way up, that is always going to be the denominator. And this is the general example here, which would be important to write down in your notes. So we're going to take these two examples and we're going to write them in exponential form, keeping in mind any exponent rules you've learned in the past. So the number 1 is pretty straightforward in that we have a squared and it's the 7th root. So all I have to do is write my a again, and then you have the exponent is the numerator and the denominator is the kind of root that you're doing. And so a to the power of 2/7 would be our answer here. Number 2 is a little bit more involved, but our first step, since we have a 5z inside the radical and it's a square root, we basically can put 5z in parentheses instead, and it's being raised to the 1/2 power, and the 5 would go on the top. So I have the exponent of 5 on top and the square root that's happening for both things on the inside. So now technically we could try to do then 5 to the 5/2 power, and then z to the 5/2 power. So the z part is done here, but with 5 to the 5/2 power, we have some extra work to do. But we're going to kind of hold off on evaluating this. We're just trying to write it in exponential form, not necessarily simplify it quite yet. So with both of these, we're writing these in exponential form again as well. So we have a cube root of 4x with no exponent. So that just means that we can write 4x in parentheses. And then since there's no exponent, that means it's a 1 in the numerator. And then our cube root means there's a 3 in the denominator. For number 4, we have a 3 on the outside, and then a 4 is our radical index. So we can just put, if we're just putting in an exponential form from radical form, which it's starting out in, we can put the 3 as the power in our numerator and the 4 as our denominator, because it is the index of this particular radical. So that takes care of writing things in exponential form in this lesson. So now we want to go backwards and practice a little bit of the opposite. So we want to look at the rational exponent and turn it into radical form. In order to do that, we're going to look at basically putting it in two different ways. So I know that the 3 is a numerator, so I could just raise my x to the power of 3. The 2 is the denominator, so I can just make a square root where you don't need to write the index. You could also write that equivalently as x, the square root of x, being raised to the third power. Important to remember that these two are completely the same. And for the one on the right, all we're doing is putting in radical form, so we can do 6x. Actually, let's kind of back up and write the easiest way possible. So the easiest way to write this particular one would be to write the 5th root of 6x and then put all of that in parentheses and raise it to the 4th power. That's an easier way of writing than just the parentheses and the 4 on the inside. I think that's a neater way of writing it. But you could also just put the parentheses around the 6x with the 4 above it, and then do the 5th root radical around all of it from there. And we have 2 more examples of turning it into radical form to practice. So now, because we have kind of all this stuff going on, so let's kind of do the opposite of what I said before so I can demonstrate this. So now we have 9x in parentheses, and you're raising it to the numerator power, and you can do a 7th root for that answer. And then we'll just do the opposite for the one on the right. So the one on the right, we're doing 5x to the 5th, and then we are doing a 8th root, and we are raising that to the 3rd power to finish that up. With those last problems, we are going to wrap up there with part 1 of the rational exponents lesson. In part 2, we will start looking at applying these rational exponents rules in order to simplify some problems and do a word problem to wrap up as well. And I'll see you in part 2 of the lesson.